Hey, welcome to Weld.com, home of TIG time. Hi, I'm Mr. TIG, and today we're going to do some specialty welding. When I say specialty, we're going to do some titanium welding. And it is special because you have to do some very special things to make sure that you get good gas coverage. Now, titanium is a reactive alloy, and what that means is that you've got to have an awful lot of gas coverage on it for a long period of time. It's not like stainless steel where you get gas on it and you can weld. When you finish, it's easy to take the torch off. This material heats up and it starts absorbing oxygen. So you got to have argon on it inside and out until it gets well below 800 degrees Fahrenheit. A lot of people like to take it down to 600 degrees. So we're going to attempt to weld some fairly thin materials. And this is like 35 thousandths wall thickness, may even be a little bit less. But in order to be able to be successful, we can't use the standard setup. We're going to use this setup right here. This is our jumbo gas lens. I've got a 1/16 diameter tungsten on it. Now, in industry, you'll see an awful lot of tubular type components like this, and you can weld it several different ways. One is eventually we're going to do a clamp on. We'll do a little orbital weld with it, and that's coming down the pike. But today we're going to rotate the part. This is going to be an autogenous weld, so we're just going to set the machine up very low amp. So we're going to put a pulsing in there, and I've got a high-low pulsing. It's about a 50% background current. I'm running at 30 amps, so it's going to average somewhere between 15 and 30 amps. It's pulsing at about 20 pulses per second. So when you see the fluttering, I put that into the machine. So let me get my gear on. I'm using an Orbiturn digital turntable from MK Products. I've got it turned down to, I've got about almost the lowest setting on here, 0.3 RPMs. So you're going to be able to see this close up here shortly. So let me get my gear on and I'll get back with you. Okay, I got a pulse on here, and it really flutters the material together. So I'm welding this without filler, and it's very compatible doing that. Got a 50% background current, so you can see it. Kind of go liquid solid, liquid solid. But you can basically get any pattern that you want out of this. Okay, so I've rotated 360, and I'm going to taper off. And okay, the weld is finished. Okay, now that I've finished this weld, I just want to kind of recap to you what I did and some of the concerns about welding titanium. You know, you hear the stories that you have to put everything into a purge chamber and fill it up with argon. Well, no, you don't. And you don't even have to have a trail cup as long as you're doing really thin material. Now, how do you know when you put a trail cup on or not? It's when the color starts changing. Whenever you cannot shield enough to keep a nice silver color, and silver is the ideal, you can get a goldenrod or even a slight brown. And you'll see in the heat affected zone just slight color changes. But look at the weld and the heat affected zone. They're both silver. So it's a good weld, it's a clean weld. If that starts getting blue, then you're probably going to have to put a trail shield on or some other kind of device to get the argon to shield. So jumbo gas lens, I'm introducing argon into the backside of this. I ran this at, ultimately I ended up going to 45 amps, putting it on a pulsar. That pulsar averaged it out somewhere around 30, 35 amps. So anyway, nice little titanium job. I do want to make a shout out to the Cobra Turn people, MK Products. This without a doubt is a product that I would have on my shelf anytime. I'll use it. So thanks for watching TIG Time. I'm Mr. TIG.